When a potato was cut in different angle or position, the cross-sectional area were quite different. Generally, the shape of this cross-section are irregular. There is one and only one largest of cross-sectional area. The largest cross-sectional area is called largest project area. There is also a smallest project area. In this video, we will learn how to use different methods to determine the area of irregular shapes, such as potato project area and surface area. The tools and equipment needed for the measurement, including caliper, overhead projector, rulers, engineering graph papers, labeling tape, planimeter, knife, paper towel, sample trays, and so on. There are two methods to get the largest and smallest project area of an object, like a potato. One is called orthographic projections. Another is called perspective projections, also called central projections. Perspective projection can magnify the actual dimension of an object. The ratio of projection dimension to its actual dimension is called scale factor. The scale factor of perspective projection is generally greater than 1. But the scale factor of orthographic projection always equals to 1. Orthographic projection is widely used in mechanical drawing. Perspective projection have been widely applied in architecture drawing or overhead projector and many other applications. If a potato is properly put on an overhead projector, its largest and smallest project area can be obtained by perspective projections. According to the largest and smallest project areas, the three dimensions of the potato can also be determined. The area of regular geometric shape can be easily calculated by using existing formulas. However, there is no single formula to directly calculate the area of an irregular shape, such as project area of a potato. There are at least 3 different methods can be used to determine the area of irregular shapes. The first method is to divide an irregular shape into many regular or very close to regular geometric shapes, and then use the existing formula to calculate the area of each sub-irregular shape. At the end, the area of original irregular shape equal to the summary of all area of the sub-irregular shape. Since this method is complicated and not very accurate, it's not required to perform in this lab. The other two methods we will use in this lab are engineering graph paper and planimeter. Engineering graph paper, also called square paper, graph paper, or grid paper, which is printed with regular grid in stem dimensions. They are widely used for plotting graphing or drawing data curves in mathematics or engineering study. Depending on the distance between the grid lines, they are quarter-inch, 1/5, 1/10, or other size of engineering graph paper. The area of grids are standardized, so-called stem square. The smaller stem square, the higher accuracy. In this lab, 1/10 engineering graph paper is used to estimate the area of irregular shape. The first step is to outline the irregular shape on the engineering graph paper. The second step is to count the total number of stem squares inside the shape. The third step is to calculate the area of the irregular shape using the total number of squares multiplied by the area of a stem square. An ordinate is to count the total square number of the shape through subtracting the square number of outside the shape from the total square number of the minimum circumscribed rectangle, and then calculate the area through the same procedure. The lab is studied with measuring the three-dimensional size of a potato using a caliper. Firstly, measure the major diameter, and then the intermediate diameter and minor diameter. After that, turn on the projector to measure the project area of the potato. Put a 1/10 transparent engineering graph paper on the projector, and then put the potato on top of the engineering graph paper. Adjust the potato position to get the largest project area on the screen. Outline the shape of the potato project area. Measure the projection of major diameter for calculating the scale factor, and then measure the projection of minor diameter to calculate the scale factor again. This scale factor should be the same or very close to the scale factor obtained from the major diameter projections. After that, divide the project area into multiple largest rectangles as possible. After dividing the project area, counting the total square number inside the shape of the project area, and then calculate the project area using the total square number multiplied by the area of the stand square. The second part of this lab is to estimate the surface area of the potato. The first step is to either completely cover the potato surface using a label tape or carefully peeling the potato surface off, and then lay out the tape or peels on an engineering graph paper to get the shape of the potato surface area. Similar to the method we use to determine project area, the surface area can be estimated using the engineering graph paper. Planimeter is a simple tool to directly estimate the area of any irregular shape. Pivot the planimeter at any point on paper to measure area of the shape. Zero the start point. Run the tracer all over the area, and then read the area number. If needed, the reading value should be multiplied by the scale factor to get the real area. There may be different types of planimeter, but principle and use are similar. After collect all necessary data, next step is to perform the data analysis in the lab report. Calculate the scale factor, project area, surface area, and roundness of the potato. Collect all this data from your team member, and then perform regression analysis on the surface area and roundness versus each of the three dimensions to find out the best prediction equation of surface area and roundness. The roundness equal to the largest project area divided by the area of smallest circumscribed circle. This is an example of data summary for a lab team. Perform a regression analysis on surface area versus major diameter. Perform a regression analysis on surface area versus intermediate diameter. Perform a regression analysis on surface area versus minor diameter. Find out the best prediction equation of surface area is related to the major diameter with the largest coefficient r squared. For the roundness of potato, Perform a regression analysis on roundness versus major diameter. Perform a regression analysis on roundness versus intermediate diameter. Perform a regression analysis on the roundness versus minor diameter. And then find out the best prediction equation of roundness is related to the minor diameter with the largest coefficient r squared. In this case, even the best r squared was very low. It means the roundness was not linearly fitting well with any of 3 dimensions of the potato. Actually, this measuring method of irregular area can also be used for AI application in precision agriculture, such as identification of different plant leaves, survey, mapping, or many other applications.